Welcome back. Today we'll be able to use a compass and a straight edge to construct an angle congruent to a given angle and the bisector of a given angle. We'll also be able to use the angle addition postulate. Let's start with that angle addition postulate. Basically, angle addition postulate is just fancy phrasing for add two angles, add two smaller angles together. Now, they do need to be adjacent angles, so let's make sure we say that. Add two smaller adjacent angles to make a larger angle. Similar to the segment addition postulate where the segments were next to each other and we added them. Well, what does that look like in a picture? Well, here's one angle, PQR. Let's say that that angle is maybe 40 degrees. This one right here. Then we have an angle next to it. I'm going to outline it, angle RQS. That angle next to it, well, maybe that's 30 degrees. And then we've got the big angle from P through Q and out to S. That big angle puts the two smaller angles together, meaning adds them up, 40 plus 30 to make the 70-degree larger angle that we see there. So how can we write that with our symbols? We can say it like this. The measure of angle PQR, remember that blue one that I traced first from P through Q to R, plus that little angle that was right next to it that I traced in green, RQ to S. Whoops, let's stay consistent and say the measure of angle RQS. All together, when we put them together, equals that large angle PQS, the measure of angle PQS. That's how we can use the angle addition postulate. Now today we're going to talk about copying and bisecting angles, and this may come in handy. Let's start with constructing an angle congruent to a given angle. An angle congruent to a given angle. Another direction you might see for this is something like copy the angle. Copying an angle. What does that look like? Well, you start with an angle. You're going to be given an angle. You may be given other stuff like a line or a ray like in this picture, but you start with an angle. Now, you probably don't have these tools at home, so you're going to have to just watch the steps and take note of what they are as I do them here. So again, I've pulled out my compass and my straight edge. The first thing we need to do when copying an angle is to start with one of the sides of the angle. That's usually the most helpful. So I'm going to grab my straight edge and use it to draw one of the sides of the angle. So I'm going to draw it, and it doesn't matter how long it is because remember the angle is made up by how far apart the sides are, how wide it opens, not how long the sides are. So I'm going to start with that. Then I take my compass and I put it to the vertex of the angle. I put the center or the needle of the compass to the vertex of the angle. Then I need to make sure my compass is open wide enough so that it intersects through both sides of the angle. So I've got the compass on the vertex. That's the important part. Starting point, very important part right there. That's where we start. Start the compass there. Always on the vertex of the angle. For any of our constructions for an angle, really, start the compass there. Then we'll draw the arc through both sides of the angle, like that. Now, we want to copy what we're doing. So anything we do here, we're going to do it here. Copy, 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 because we're making congruent. So we're copying. Let me move my ruler out of the way. Vertex down to what will be the vertex, the end of that segment, and then draw an arc. Now, I tried to draw it about the same size, but bigger will make certain that I'm not going to miss anything. So I drew that first arc. Copy the arcs that I made. So draw an arc, arc through the angle, copy the arc. So first arc here, second arc here. Number where we go. Start the compass, first arc, second. Try to copy that arc, or longer isn't bad. Now we use our compass for a measuring tool. So we take our compass, we put the center at one intersection point and shorten it to measure how far apart those two intersection points are, like this. Now, we're just using it to measure. We don't need to mark up there. I just want it to be the exact same size. Remember, copying. So we're going to put the exact same thing that we did down there, and now I'm going to mark an arc so I can mark how wide apart it is, because I need to mark it there. So that's that third thing. We use our compass to measure the distance between there. So measure the distance, and then draw the arc to show the distance. Okay, so drawing the arc to show the distance. Now we just need our straight edge, and we connect it, and we've got it. So let's bring our straight edge back. We're going to need to rotate that around and rotate a little bit that way. A tad, and that might be good. All right, let's check it out. I'm now gonna, from there and through the intersection point. Did I make the same size angle? I might have to bring out my tracing paper or my protractor, but I think we've got it. So last step, draw that last side. Draw the second side through the intersection. And you've got it. Now let's construct an angle bisector. Remember, that means bisecting, cutting in half. So we're going to cut an angle into two congruent angles. Now, anytime that we're doing anything with an angle, the most important part is the vertex. Always start at the vertex. Always start at the vertex. That means we're going to take our compass and put the center of it, or the needle, on the vertex like that. So first thing, put it at the point that is the vertex. Then we can swing an arc that goes through both sides. Does this sound familiar? This is what we did when we were copying an angle as well. So swing it through both sides like that. So it swings through both sides. That's our first step. Starting point is the vertex, and then make sure you draw an arc that intersects both sides of the angle. Has to intersect both sides. Now those intersection points become the next most important points. So this point right here where the arc crossed, this point right here where the arc crossed. Those are the next starting points. So now center of compass, or the needle, goes on those intersection points. Now let's look at what we do when we put it on the intersection point. Now I want to make sure my compass is open at least past halfway of the opening of the angle. Mine's open pretty wide, so I actually don't need it open that wide. I'm going to shorten it a little bit. Now I'm going to draw an arc that goes in the interior of the angle. It doesn't have to be huge, but in the interior. Go over to the other intersection point and draw an arc that crossed the arc we just made. So look at that, two arcs that I drew. So from that intersection point, we've got these two arcs right here that cross at another point. So what did we do? From this two intersection points, we draw two arcs that intersect inside of the angle. Now we're basically done. We just have to draw the bisector. So now we grab our straight edge and we connect from the vertex through that intersection point. So let's line it up. It's almost lined up, just a tad more. And let's see, rotate it just a little bit. And that's almost right. That's about right. Now we can draw from the vertex along our straight edge through that intersection point. Often you'll see a bisector made as a ray, but now you have two congruent angles. This angle right here is congruent to this angle right here, so I'll put my angle congruent marks. So my last step right there was to draw that intersecting, that bisecting ray. Draw the bisecting ray through the vertex and the intersection point of those two arcs from the last one. And there you have it.